Welcome to our introduction to digital logic for Redstone, right? And this is mostly sort of an introductory thing that lets us sort of combine our. Can you do? Yeah, you can totally do this on your Switch, by the way. The server does not work for Pocket Edition. Oh, and by the way, feel free to throw questions out there whenever as we go through. This is supposed to be like an interactive workshop, right? Like if you're in person, we just come over and help you. But not letting you join, I would hit up the Minecraft Slack, um, or maybe Priyanka can help you out, or Hannah if you're gonna stick around.
Yeah, we'll be here.
Sweet. Okay. Awesome. Yeah, Diana, I would just let them know, and they might be able to help you out. I'm not really involved in the administration of the server itself. But yes, to answer all your questions, so for everybody, we're going to basically be combining our knowledge or like sort of our interest in computer stuff, right? Um, with this redstone system that Minecraft offers us. Now it's great because we already have this inbuilt interest in Minecraft, and we're already kind of studying maybe or interested in computer stuff in school, and it's great because we have this sort of opportunity to converge the two skills that we have in a really productive and neat way in terms of building stuff with Redstone. So that's kind of the focus of what we're building here. I'm going to take us through some of the basics, um, kind of build in some of the curriculum that we've been looking at in college already, and then kind of finish off with some neat build ideas and kind of just how to apply what we've learned. So that being said, let's go ahead and get started. But I did want to include this little bit right here, just because this is the event that we're at, and I do want to mention that I'm sure at this point in time, many or most of us have been victim to toxic treatment, harassment, and of course misogyny in video game communities online. These are notorious for perpetuating these sort of environments. Now, especially I used to play video games a lot ever since I was a kid. And services like Xbox Live, PlayStation Network, even Minecraft servers, places like that. I've seen my fair share of this stuff, right? And it's real. It's a real issue. I think we shouldn't forget that this is something that exists, uh, and we want, to get rid of it. So I just want to say before we start this workshop, first of all, I'm so glad that all of you are here, and second of all, this is important. If your interest in video games was ever, not taken seriously because of who you identified as, um, let's establish that it's not going to happen here, and of course that you have allies, right? Um, and building off of that, one more thing generally in computer science, right? We can sort of generalize this. If that was ever not taken seriously because of who you identify as, please understand that it won't happen here. You have allies, and of course, this goes without saying, but let's keep this a safe space. So, again, I'm so glad that everybody is here. And I just want to establish that this is a safe space, and our goal should be to expand this to all video game communities. Um, what have you, and of course within computer science. So just wanted to throw that out there and make sure we're all on the same page with that. And I'm so glad that Technica is giving us the opportunity to provide this workshop for everybody. So that being said, uh, great, thank you. Just wanted to go ahead and get started. Get ready to build some damn cool stuff, right? Whoever you are, this is that's what we're going for. So, what is this workshop, right? So we have a general idea of what it is, but here's what we're gonna sort of get through today. First of all, we're gonna go through Redstone and Minecraft. Now, I'm assuming that everybody here kind of has an idea of what Minecraft is, but I've taken the liberty to write up some literature in case where, oh, is the Minecraft piano, is that coming from my computer by chance? I hope it's not. Okay. Oh, okay. All right. All good. Yes. Okay. Thanks. But yes, so we're gonna do a quick introduction to Redstone and Minecraft, just because that's the basis of this whole thing. So no worries if you're starting off with just a basic idea of Minecraft in general. Then we're going to try to make a bridge, right, between digital logic and discrete math, which is where we sort of get our computer science stuff, right? And the aforementioned Redstone. So I've kind of this is a little graphic here. I feel like is a good way of explaining what we're doing here. So what we've learned in class is on the left side here, and then this business, Minecraft, where we'll be talking about a weird blocky video game that your parents don't understand, and building efficient, intricate Minecraft systems, right? So we have the neat ability to have this sort of education kind of trickling into us already, and we're going to use Minecraft to sort of make, to build upon those ideas and make some cool stuff. And finally, a neat look at what is possible when combining your knowledge as computer-oriented individuals and the mechanics provided in Minecraft. So that's kind of an overview. Um, so yeah, the TLDR is this: you're computer people who like this video game, which means you have excellent taste, number one, and two, you are uniquely positioned to allow your two interests to converge. So let's go ahead and do it. Let's jump right in. Right. So here's a more specific list of what we'll be covering. Right. So first, an introduction to Redstone, everything you need to know, kind of like a refresher. Then we're going to build some basic logical circuits with Redstone. Right. And I've got some demos that we'll totally look at. Going to build. Um, a circuit called a half or full adder using logic gates, right? And then we're going to apply what we learned to build these further things, or to at least look at examples of these further circuits, right? And the goal here is to kind of make ourselves more efficient at building these structures in Redstone and kind of understand the basics of how the system actually works within Minecraft. And again, I just want to say that this workshop is kind of malleable, right? If we get if some part isn't really like making sense, or if maybe I went over something too fast, feel free to throw it out there and we will totally go through it. Cool. So who is the person teaching this workshop? Just wanted to throw this out there. This is me, I guess, since you're not seeing my face in person. There it is. That's my face. Email address is there. If you have any questions about this at all, like after the workshop or anything, just feel free to like mail them to me. I have to check my email anyway, since I'm a 216 TA and Larry makes us check our email every day, twice a day. So I will be getting back to you pretty quickly. So feel free. Um, and oops, wrong tab. There we go. So I'm your host. Just wanted to throw a little bit of stuff in here about the people that are teaching this, which is me. And it's just the CMSC 389E class here at Maryland. So I've just condensed some of our lectures into one small workshop. So that's basically who is providing this workshop. Let's talk a little bit about Minecraft. So starting at the beginning, Minecraft is a voxel-based sandbox game that became widely popular during our childhoods and still enjoys an immense amount of popularity today. I just threw this slide in here in case people are joining and have no idea what Minecraft is, right? This link right here, which I can, I think, so I'm gonna copy it and paste it in the slide set here. It's from our class textbook, and it just talks a little bit about, what is Minecraft. I'm not gonna dwell too much on it right now, but in case you're new, just figured I'd throw that in there. So moving on, I'm sure we're all sort of familiar with the idea of Minecraft, where you can build whatever you want in an infinitely scaling universe, right? And people started off by building castles and buildings and stuff. But another great, humongous aspect of this game is, well, okay, here's just a picture I figured I'd include. This is of this rendition of Berkeley that Berkeley students built last semester when they couldn't graduate in person, so they had hosted a graduation in Minecraft, and that is some chunk of their school that I assume is very important. Um, but just to, that is what people use, I guess, Minecraft for. A lot of people just to build. But another great aspect of Minecraft is Redstone, right? And it's an excellent way to emulate digital logic and circuit design within a video game. Um, and it basically allows us to emulate wiring in the real world, except within Minecraft, affording us constructs like energy sources, wires, repeaters, right? And although these constructs within Minecraft are not exact counterparts of real life circuitry, they're basically close enough for us to use our like CSC minds to put some cool stuff together, right? Our logic from real life still works on the redstone in this game, which is excellent. And another great point that I didn't put in here is that we have infinite resources in Minecraft. If you wanted to build like an analog circuit or a clock in real life, you go out to like, I don't know if Radio Shack's still a thing, but Radio Shack or something, you buy wires, put them together, get a breadboard, maybe an Arduino, right? That costs money, it takes time. In Minecraft, you just put a few things together and you can see a very real representation of this. Um, so, great game, great opportunity to learn. So what do you do when you combine ultimate unlimited building resources in space, a neat wiring system, and a few spare hours? A whole new world. I have a little Disney reference in there, and of course, my personal answer is mediocre secondary school performance and the crippling video game addiction. But I think it was for a good purpose at the end of the day. That's just a little humorous aside there. Now we're going to talk a little bit about Redstone in a few minutes. Now I know I'm throwing a lot of words at you. I just figured I'd get the intro stuff out of the way. But if you haven't already, please take this time to hop on the Technica Minecraft server. The link is right here, and Hannah's been great enough to throw the IP up on the Zoom chat. So even if I go past this slide, you can just scroll back up and you'll find it. Um, I see people joining. That's great. all you have to do is show up on the server and claim a plot on there. Um, and I think so. We've got organizer Priyanka here. I think if she's been on the server, she can totally help you out with that. Um, we'll talk a little bit more about that when you get your like first task to actually go through. So just go ahead and get on the server if you're looking to do it on the server. Otherwise, if you're playing on your Switch or console or Pocket Edition, just open up a new world in creative mode, and you should be good to go that way. All right. So here are the blocks we'll be focusing on. What did I type in? I typed okay, okay. So that looks like a question answer stuff going on. Right. Continue. Yeah. Right. So here are the blocks we'll be focusing on. Right. Um, this is where you can find them in the creative mode menu. You click the Redstone tab, right? And you should see these different constructs. Now, a lot of the stuff we see in here are super neat things that we can use in Minecraft, and they can all be manipulated using redstone, right? The cool wiring system in this game allows us to either produce signals or receive signals using most of this stuff. But the main things that I want to focus on today are the bread and butter redstone, the real building blocks of it, so to speak, right? Oh, perfect. Thanks, Priyanka. That should give you instructions on, I think, how to get a plot and your own creative section going. Um, so I want everybody to kind of remember these three as the main, building blocks, bread and butter uh, of Minecraft, right? And I am on purpose running in windowed mode so I can just kind of go through it. I have taken the liberty here to hopefully everybody can see Minecraft up. I hope, yes. Um, Perfect. Thanks so much. Appreciate it. Okay. So if you go ahead and open up your creative mode menu, right, after you claim a plot, so I have claimed this plot for my own. I think I can like edit it. Yeah, okay, great. Um, and what you can do from here is, so the menu's gotten a little bigger than when I took the screenshot. But you want a redstone torch, that's one. The redstone dust, we've got that. And of course the redstone repeater, which is floating in here somewhere. Ah, there it is. Okay, redstone repeater. So not in the exact same place as what I've got in the screenshot there, but you can find them in the redstone menu here. And this is the stuff that we'll be focusing on, right? So let's go over a quick overview of the components. How do I bring up the chat and settings menu? You press E to do inventory, E inventory, T for chat, and slash for commands. So that should hopefully be the stuff. The settings menu is ESC, by the way. So here's our redstone torch, right? Um, and I just want everybody to think of this in terms of like digital logic, quote unquote, on and off, that sort of thing. Um, so the redstone torch, as you see here, is the source of an on signal. And if placed in a certain way, can be used to invert specific signals, right? I figured I'd give you a live demonstration just to make it a little easier to understand. So let's take a look at it this way. Here's our redstone torch, right? And as it sits right here, we can note that it produces a positive redstone signal. That is the any wire connected to it or any redstone stuff connected to this torch will be on. So we can see that this wire is in an on state as I've connected it to the torch. And if I remove the torch, that wire turns into an off state. On the subject of wire, let's move on to this next slide, redstone wire, right? So this is how a signal can be produced. There's just one way. And this is how a signal travels, right? And when we talk about redstone wire, if it helps, I'd just like you to think of copper wire in real life, right? What does copper wire do? If you provide energy, like electricity from one side, the copper wire will conduct it and let the electricity run through it, right? Same deal here. So think of it this way. We place some copper wire down, we put a torch here on this left side, and that energy is sort of generated and runs through just like that, right? And again, note if I break the connection, then this copper wire here is obviously not powered. Redstone wire is not powered, so nothing's going through it. Throw this down again, and we've got power running through. So this is how the signal travels, right? And we can kind of extend this however we'd like and let that signal go to anywhere. Next, I do want to mention that wire has two states, on and off, right? And the strength of the on signal can vary, but the signals are still very much binary. Here's what I mean by this. On means the same, or like a weaker on means the same as a stronger on. Um, so if you'll notice, when I've got the wire here, Minecraft has this additional little construct that they have where if you start a power source, well, let's lay down some wire first. We've got a bunch of wire going, and if we start a power source right here at the left, we can see that the signal is on, but if you'll notice, the strength of that signal gets a little lower as we proceed. So you can see over here, it gets a little darker, until finally our wire is just off. Might take a few more than that. Ah, there we go. This one is just off. So you can see that it's kind of limited, right? So this torch produces an on signal, and over here we have on, all the way up until this limit, which I believe is 15 blocks, and the signal turns off. So it's a limited strength signal. And you can imagine there are plenty of reasons they implemented this in Minecraft, but a cool fun fact is one of the big reasons they did this is because, well, um, wait, hang on. Uh, okay, you're good. This is, oh, there we go. Okay. Um, so one of the cool reasons that Minecraft has implemented this is because if you were to have infinitely long wire and perhaps a energy store starting at this, say, a billion blocks, right? Minecraft would essentially need to update a billion blocks with this on signal, all the way from here until there. So they really do this for a pretty real reason, and that is to limit the uh, ridiculous amount of time it would take to update like this on state um, within Minecraft. So again, feel free to ask any questions as we continue. But that's sort of the gist of wire. And finally, we're going to talk about the repeater, right? And going off of what we went on before, the redstone repeater basically extends the on signal, right? And resets the strength of that on signal to full. Um, it also adds a delay that we'll discuss later, and finally acts as a diode, right? So it only allows current to flow one way. Again, a great live example of this is observe that we're starting the signal here. It continues all the way down, and as our signal is getting a little weaker, we probably want to say, okay, let's extend this, right? Let's allow this signal to continue. So we can take this block right here and throw it on a repeater, and what this does is it essentially resets the strength um, of the redstone signal coming through, right? And the reason these are so useful um, is best demonstrated by something like a lamp, which will light up only if provided redstone power to, right? So notice here, now we've got the redstone lamp and it's powered because we have a signal starting here, gets a little weaker as it gets to this redstone repeater. The repeater renews its strength, um, and then as it's renewed, the signal is very strong. It comes out and powers the lamp, right? Again, let's say we got rid of this torch, you'll notice that since there's nothing coming into the repeater, it doesn't have to strengthen any signal, and the lamp is therefore off, right? One more thing about repeaters. It doesn't allow current backflow. So that's what I mean by it's a diode, right? So repeaters will strengthen it going in one direction, so this is fine. The repeater has strengthened the current coming from the left going to the right, and that's all good. But suppose we try to run current the opposite direction from this way. The repeater will stop it where it stands and not extend it backwards, right? So that's the basics of the wiring system here, and it's pretty neat as it is. And of course, I've got some more info. Basically, everything that I just said is in the form of like a nice website that you can scroll through and look through and kind of read at your own on your own time, at your own pace. I'm gonna go ahead and throw that link. And by the way, I'll share the slide set with everybody after we're done with this, so hopefully should be totally fine. Um, but that's a little link that basically talks about everything that I mentioned, just written down, so you don't have to kind of look back at the recording or scroll through the slides and kind of figure it out for yourself. Hopefully that link should take care of everything for you. But yes, that's a little pocket reference about Redstone in Minecraft. Right. So that's the basics of Redstone, right? But I'm hoping that at least a few people kind of have an idea of what Redstone does already within Minecraft. What I do want to talk about is now the convergence of this Redstone that we've learned about with some concepts that you've already seen. So if I can kind of see if we can leverage the zoom feature here, can I see some hands of people who have taken maybe CMSC 250 or discrete math somewhere? All right, I see some hands, solid. And feel free to throw it in the chat too if you've taken like what CS courses are we in if we are in at all. I guess that's what I should be asking first. Feel free to throw it out there. Oh, solid. Okay. All right. Cool. Looks like we really run the gamut here. Oh, UD, excellent. All right, Java and discrete math. Oh, awesome. People in high school, great. It's great to see that. Okay, we got a wide range of people coming in. So if you're in APCSA, I feel like this might be a little bit past where you're at right now. But all backgrounds, yes, I agree. All backgrounds need this information. Excellent. Wow, algorithms in high school. Your high school's cooler than mine. But basically, what we're trying to get at is, and by the way, if this is a little confusing to you, I can make an analog to APCS, and that might hopefully make it a little clearer. But we're going to explore the logic gates, right? The understanding of the logic gates and translate that into Redstone. How are we going to do this? By going step by step, making clear connections with the Redstone concepts that we already know along the way, right? So let's go ahead and get started. Let's think about logic gates as they are, right? Usually we have things like, I'll go ahead and throw them in the chat too. We have things like and, or, I believe we have XOR as well. That's kind of sometimes you might not have a like a dedicated XOR operator, but really what we're looking at are the actual gates, right? The diagrammed out two inputs, one output kind of gate, right? So if we haven't taken a look at that already, why not throw it up on the screen? Because I think this might be good background for everybody. Digital logic. Ooh, and if you hear background noise, that's because we are currently ground zero for a lot of Technica operations. So I think they're like making food or something outside, which is probably what the noise is. Okay, let me throw up a cool link. And by the way, you all have access to these links as well. I'm going to put them in the presentation very soon. But let's look at them, right? So here's what I'm talking about when I say logic gates. We're talking about NOT, right? Which basically just takes in input, inverts it, and sends it back out, right? Um, and by the way, is anybody here totally unfamiliar with what I'm kind of going over right now? The logic gates and stuff like that. Ooh, okay, no problem. Yes, we'll totally take it slow. So not think of not almost like the exclamation mark, right? If you're thinking of maybe computer science, basically all you need to know is that whatever signal is coming in to a NOT gate, right, which is just a construct we're going to build, that signal is going to be inverted. If you have true coming in, you're going to have false coming out. Perfect. Thank you, Blade. And if you have false coming in, you'll have true coming out the other side, right? I think, Sophie, this might be a lot clearer once we take a look at an example. Um, while we're on the topic, though, we can take a look at some more advanced gates, right? You might recognize this construct idea from computer science as well, but this is the AND gate, right? And the AND gate is only going to give us a true output um, if this coming in is true and this coming in is true. So if both inputs are true, then our output is going to be true. Otherwise, we will produce a false output. And that's kind of what this truth table on the right is describing. So no sweat if this is totally new, strange stuff to you. I highly recommend you take a look at the diagram that we're gonna, or like the actual circuit that we're gonna build, and this probably will make a lot more sense, right? Same thing with OR. And XOR. So we'll kind of go through them and talk about them as we move along. But first, I want to talk about actually building these gates within Minecraft. And we have to understand the input for a logic gate is composed of one or two values, both of which can either be true or false. Again, great examples here with these truth tables that I've got, right? Inputs can be true or false, and the outputs are decided accordingly, right? And let's represent these inputs as redstone wires. A wire with a current is true, and a wire without a current is false. So this is what two false wires would look like, right? Two false inputs. And this is what two true inputs would look like, right? So I'm kind of trying to draw the analog with Minecraft here, and we can go ahead and pull up the Minecraft window. Let's go ahead and kind of build a little analog to that. All right. So just like I've got in the presentation, these are two false inputs, right? Again, if we wanted to provide a true input, we'd just turn the wire on, right? So that's good. We're kind of looking at it that way. That's fine. Can we think of outputs in the same way? Absolutely, right? Inputs and outputs, they're all wires. That's kind of what I want to emphasize here. Output can be represented by a single redstone wire coming out of our logic gate. If that wire carries current, it has a state of true. If it does not, it has a state of false, right? So hopefully that should make sense. Again, feel free to stop me if it's not making sense. We can totally go through it. So here's what we've got so far. We've got input and we've got output. Now I'm sure everybody is impatient to know how exactly we would actually build these gates, how we would get this little question mark demarked off bit correct in the first place, right? So again, I hate to kind of stall everybody out, but so we've got these two inputs, and somehow we want to do something to these two inputs to produce the right output. So in other words, if we wanted to build let's say a NOT gate, let's start with a NOT gate. That's the simplest. And for that, we only need to really pay attention to one of these input wires because a NOT gate only has one input wire. And our goal is to say, well, if we have on coming in here, we want this to be off. But if we have nothing coming into our input, right, let me just do the NOT gate over here, actually, might be a little better to understand. So if we have on coming in, we want our output to be off. Inversely, if we have off coming in, we want our output to be on, right? Does everybody understand that? Or again, I will keep asking that, but feel free to take that as an invitation to say something if you don't get it. But if you do get it, then no worries, just don't say anything. It's a lot different from like in-person discussion, I guess. Um, so we want to do that. Here are some nuances to remember when building in general. So a redstone torch, when placed correctly, will invert current, right? And repeaters, as we already talked about, will extend current and act as diodes. So you're welcome to use comparators as well. It's totally viable to use them to build these logical circuits that I'm talking about. I just tend to stay away from them because they were dropped into Minecraft a little after I started, and I feel like they're not great at perfectly representing the analog or the analogy between real life circuits and Minecraft circuits. But tomato potato, or oh, I messed that up. That's fine. Tomato potato. Okay, right. Um, our goal now is to turn this into a NOT gate, right? So let's go ahead and do that. And I just want to show you how to use the resource that I'm providing to kind of figure that out. Um, and this is where we're going to start getting started on how we build these gates, right? So your goal now is to build these gates, NOT and or an XOR. And I want to show you how the website will help you kind of get through this, right? So let's take a look. This website that I'll be linking in the chat here provides instructions on how to build NOT and or give it a second here, it's kind of slowing up, and XOR, right? All of these gates, totally possible in Minecraft. And you can see a live demo here if my code worked. I suppose not on Firefox. Okay, all right. Well, if you have Chrome, that totally works. Um, see if I can just throw it up in Chrome here. Boo. We'll give it a moment to load the project. Great. This is how you would build an inverter in Minecraft. And by the way, on the website itself, you can use WASD to kind of navigate around this little um, frame that I've got on the website. But this is how you would place a torch in order to build an inverted gate. So I'm going to kind of walk us through using this website's walkthrough and how to build a NOT gate. And I want everybody to try and build the AND or XOR, right? And in the interest of time, just try and build one of them, one of the AND or XOR, or the NOT gate, right? Just to see if you can get it working. But so you'll notice that this is what it prescribes on the website. Um, this is the input. We call that red, and blue is output here, just for the purpose of our demonstration. So let's go ahead and do that. If I can just throw up Minecraft here. Here's how you would build a NOT gate. We've got input coming in, and if we use any block, so I'll just use the first block available, stone, basically any block, right? Except for ones with special properties with redstone. And you put a torch right here in this strange little construct. That is how Minecraft defines an inverter, right? So take a look. Signal coming in, this little setup inverts it and brings it out as false. However, we turn this one off, it gets inverted, right? This is off, but this comes out to on. And you can see, if I turn it back on, it gets inverted. So this is how you'd build a NOT gate in Minecraft, right? So again, this that we just built is our very real representation of this exactly. The source is the left torch, right? And in a very real sense, the source is actually just the left side. So whatever, not just a torch, you can have another circuit, perhaps two inverters in a row, right? We could totally do that. We could do a chained NOT gate, just like this. Um, and this would allow us to basically, I mean, it's a completely useless construct. Basically, all it's doing is it's inverting twice, right? So if I placed a torch here, it would get inverted once, inverted again, and then sent back out this side. So whatever is coming in on the left side, whether it be torch or inverter or other logical circuit, it gets knotted by this chunk right here. So hopefully that makes sense. And again, feel free to ask questions. And now I invite you to take this time to open up Minecraft um, and use. I'm gonna send the link right here to the online textbook. Um, and again, we're looking at chapter 2 logic gates sections, 2.1 through 2.4. So you can click any of these, right? And I highly encourage you to try building one of these that are here. And or NOR, NAND, XOR. I've got all the demos just floating around in here somewhere. So highly recommend, right? Feel free to take a look. But I'm going to give us some time, perhaps a few minutes to kind of go through and figure this out. And while we're doing that, if you don't want to build it yourself, no problem. I myself am going to get to work building an AND gate while you all are giving this a try. And should you need help here, I'm going to lower all hands for now. And if you need help, just raise your hand and we'll come around and help you out. Or by come around, I mean, you know what I mean. So feel free to get started on this. And again, ask questions as needed. And while y'all are doing that, I'm going to go ahead and get started building an AND gate. So I'll try to keep the commentary to a minimum so you can kind of focus. Um, and just for the sake of continuity, I'll reference the guide while doing it too, so everybody gets an idea of how to do this. Let's got this. We got two inputs here. Our goal is to make an AND gate. So what I would do is hop on here, reference the AND right here, and open it in Chrome because I'm horrible at writing code that works on multiple browsers. Boop. And if I wanted to figure out how to build AND, I would just scroll down here, right? And there are reasons these constructs work. Basically just nuances with inverters. Here, we're using a fancy series of inverters and leveraging the properties of Redstone itself to build an AND gate. So I take a look at what we've got here on the demo that I've thrown up on the website. After taking a look, what I'll do is I'll say, okay, pretty solid demo. Let me just keep that in the corner while I take my real Minecraft and get to it. So just like they've got on there, I'm gonna put 3 blocks adjacently like this. And if you feel uncomfortable with building the other ones, feel free to build the and too, right? This is just kind of an exercise in figuring out how to put some of this stuff together. So I'll just add this here, add the blocks as it says on the website, um, and leveraging the nuances of Minecraft Redstone, right? You saw that the inverter was constructed in that strange, seemingly arbitrary way. These are just neat ways to leverage properties of Redstone in Minecraft in order to create these other logic gates, right? But check it out. Once we've created this construct, this seemingly arbitrary AND gate construct, which is really just an elaborate kind of series of inverters mooshed together, leveraging the properties of torches and redstone, we end up with an AND gate. And if I could just provide a live demonstration here, one input signals that this AND gate produces no output, right? Um, Again, similarly, if I disable this input, enable this input, again, producing nothing on the outside. However, if we provide both at the same time, we see that our AND gate is producing an ON signal coming out of there. And that's how you would build an AND gate, right? Again, in the interest of time, I'm not going to go over all of the gates, but the literature that I've provided, specifically the link that I've provided, gives you an overview on how to build all of the gates that we've got right here. So that's how you'd kind of get started in building this sort of um, combinatorial logic, right? These little structures in Minecraft that can do all this logic stuff for us. Um, and again, I'm going to take this moment to answer any questions that we've got about logic gates or building them in Minecraft, or perhaps with the sorry, oh, for the and. Why are the torches at the top necessary? Great question. The torches at the top are necessary mainly in short because of how strange Minecraft's torch and redstone mechanics are, right? They're basically little nuances built in. So in here, we've actually got this weird sort of inverter setup going. that basically says, okay, unless both of these inputs are on at the same time, this particular torch is not going to light. And you can kind of see that by if we disable this. Um, Here's what's going on. This is coming in as positive. It cuts through here, um, and it doesn't get outputted here. So that's one thing. If we get this here, then we suddenly have the ability to invert this block, which turns this block on. But if either one of these are on, that middle redstone bit, if I can just, the middle redstone bit will be on, and therefore inverted by this torch and sent out. So our goal basically is to design like the circuit in such a way that this middle redstone wire will be off, such that it's inverted um, and sent through this torch. So again, it's in this design and the other designs that I've got on the website that basically just leverage some weird kind of arbitrary constructs of Minecraft just to make sure, or we're kind of leveraging those to build gates that totally work, right? So I would say going super in depth, there's like, obviously an explanation for why this behaves the way that it does, but it's great to build these basic circuits as part of your like overarching larger circuits um, when you're putting stuff like this together. So I would say it's good to kind of know how this works as like a black box level. Great. Okay. Cool. So that's the logic gates. And I mean, perhaps you're kind of thinking, okay, well that's sort of basic stuff, perhaps boring, right? And I just wanted to start here because it's sort of a basis for how we're getting through this. But let's talk about logical complements for a bit. Occasionally we have a gate or circuit that produces the exact opposite of what we want, right? So I just want to add that suppose you wanted to make the NAND gate, right? You would just invert the output of the AND gate. So ta-da, you've got an AND gate. Again, if NAND is kind of it just goes over your head, no worries. That's you know just the logical complement, the opposite of the AND gate. Um, but in case you ever needed, just to produce the NAND, NOR, or other logical complement gates, all you have to do is add an inverter to the end of it, right? So I'd really like to stress that you can combine all these, right? You can have like multiple ands if you've in discrete structures, if you've kind of gone through those formulas where you have like multiple gates, right? All connecting to each other and you can simplify them. All that Boolean logic and stuff is totally possible in Minecraft, right? So you can have this AND gate connect with perhaps, we can build maybe another AND gate right here just to demonstrate. I can say, maybe we can have an, we'll call this an inverted gate. Perhaps we have something like this. We'll just make that like that. And if we wanted to build another AND gate to compound on this, we totally could, right? So you can kind of see how we can combine all of these inputs, right, into multiple gates. There's AND over there again, and there's not. I would really think about this in terms of, those diagrams that you draw in 250 where you have like the little gates as these little triangle diagram things and you connect them all together. That's kind of what we're doing. And that's what I'd like to get at in my next little bit here, right? When we can essentially take these little logic gates, and you're probably thinking, now what? Well, let's start by expanding to a slightly larger, well known example, then we can talk about much larger generalizations, right? So if you've taken discrete or enrolled in one right now, it's either to a Rutgers 250 here, you'll know about adders, right? And if it's been a while since 250 or you need an overview of adders, again, Unit 3, Chapter 1 and Unit 3, Chapter 2 in the textbook that I linked, go ahead and throw it again in the chat. Um, those will get you there. The kind of broad overview of what exactly adders are. And so I'll just quickly go over how to build something like that, right? Um, so here's kind of an overview. We can use adders, these circuits that I'm talking about, to accomplish the following. Given two binary numbers, 1 or 0, as input, right? Perform a binary add of both of them. If that's a little weird and unfamiliar to you, think of it this way, right? So given two binary numbers, if we add 0 and 0, we get 1. Sorry, 0. That was excellent on my part. Okay. If we add 0 and 1, we get 1. If we add 1 and 0, we also get 1. And if we add 1 and 1, this is a little weirdly tricky, but we also get 0 with a carryover of 1, right? But we're going to ignore the carryover for now. Um, so does anybody have any questions on the binary addition that I just put forth here? Does that perhaps seem a little strange to anybody? Okay, all good. So as discussed earlier, we're going to take input and provide output in the form of redstone wires, where on means 1 and off means 0, right? That's why binary is so useful to us when we're building computer constructs. Computers really only know on a basic level how to handle two states, on and off. So it doesn't count the outputs, and that's why the ones create 0. Um, so the real thing is the ones create 0 because it basically is 1 plus 1 equals 1, 0, right? Except we don't count that overflow because we can only represent the output as one digit. But in the circuit that we're building now, we can kind of represent the this carry as one as well. So great point. But essentially, yes. Yeah, exactly. Yep, yep. I think this will make a little more sense when we look at the circuit here. And the main point I'm trying to get across is, okay, now that we can build each of these individual logic gates, congratulations. You can build like anything that you possibly want, right? Here, I'm just demonstrating that you could build this adding circuit, right? Incidentally, this adding circuit here is the basis of calculators within computers, right? This is how computers manipulate numbers. They'll perform adds, and with a simple edit to this circuit, you can turn this into a subtractor, right? And again, here, I probably won't go through building it just because you can kind of see, just like I've done here when I combine the outputs of XOR with the AND here, you can totally do something like that in here, right? You just have to, so you could put like a XOR here and an AND gate here, and then combine their output, right? Um, and so hopefully it's kind of apparent to everybody that once we know how to build a few of the logic gates, you can combine these in any way that you want. And once you can do that, a little spiel that I have here is well, I have this little workshop task here too. So feel free to go ahead and put this together if you'd like, right? And while you do that, while you put together, use the knowledge of these little gates to put together a half adding circuit, just as I've demonstrated here. I'll kind of talk a little bit about why this is so important to us. Um, so here's the deal. Since we've already, kind of looked at building these small logic gates and we're moving on to building more combinations of these small logic gates, let's talk a little bit about functional completeness. The idea there is that a logic gate is known as functionally complete if that same gate can be used to construct all the other gates. That sounds a little weird, but there's a reason we're introducing this, right? So the NAND gate and the NOR gate, so that's inverted and inverted OR, they're the only gates that are functionally complete, right? So in other words, using a combination of NAND gates, you can create NOT, you can create AND, you can create OR, you can create XOR just by combining that gate over and over again, right? But knowing that, we can basically say that if we understand that the overlying idea in modern computers is simply just a humongous amalgamation of logic gates, because that's basically what it is, right? The system that you're running this Zoom workshop on, realistically, I mean, it could just be a whole bunch of logic gates, or specifically NAND gates, all mushed together, right? And that's the idea that we're kind of getting at. By being able to build these basic logic gates in Minecraft, we've essentially proven that we can build a computer of any size. So I don't know if you've seen those crazy YouTube videos that are like, oh, 32-bit computer in Minecraft, right? That's all possible. And we've kind of explored today how, like, theoretically that is possible, right? Yes, exactly. So in other words, if you take these logic gates, this is just like a shorter kind of workshop version, but if you take these logic gates, right, the knowledge that you have to build these logic gates, put them together in circuits like adders, perhaps multiplexers, demultiplexers, encoders, which are all, by the way, just again, big mishmashes of these logic gates, then you can theoretically build a computer. So I suppose if you've kind of at least tried one of these gates, then pat yourselves on the back because that is essentially the basis of building a computer in Minecraft, right? And that's what I'm trying to get at with this generalizing idea. Since we can make the basic logic gates, use them in basic builds, the world is now ours, right? So I've got a little bit of a spiel on this on the textbook as well, right? And I talk a little bit about the NAND gate. Um, and basically, that's what I'm kind of trying to get at here, right? If you can build these basic logic circuits, then you can essentially build a computer in Minecraft, right? So logic gates have the story here. Although we can use them to represent computing logic, we can begin to emulate other cool functions of computers with Redstone as well. So I'll try and show you some neat examples combining what we learned with perhaps some newer ideas, right? Just to kind of show you, now that we know sort of like the basics of how Redstone works and how to use the logic gates, some less theoretical stuff and some more fun stuff, because I'm sure that's why everybody is here. Um, so here's one example, combination locks, right? Um, and I did want to kind of work through this example, but I decided to throw them in as YouTubes just in the interest of time. So this is a great example to look at. And I want everybody, just as a quick exercise, if you could take a look at this and tell me like, identify at least like one logic gate you see being used in the YouTube video that I've thrown into the chat. And feel free to kind of like, skim through the video, click through it, and just throw it in the chat. If you see a logic gate, just be like, oh, this one. Um, but this is just kind of like an exercise in a real world application of, well, I mean, Minecraft world application of what we've learned. So feel free to click the link, kind of look through, see what you see, because I'm looking for like there are a few answers that are totally valid here of these logic gates. And also related, I've included a more involved example of a bank with a piston door and an advanced vault done by another YouTuber on here. Um, Again, that one's got a lot of logic gates in it as well. They're a little bit more nuanced than the ones. I mean, they're still the same logic gates, but the way he builds them are a little bit more nuanced than we talk about. But the simple example that I've linked is great. Um, so feel free to kind of click through and look at it. I mean, I'm not really throwing it up here, but I could. Ooh, it is a loud video. And it's neat. They don't look exactly like the ones that we've built, but you can see that the logic there is kind of the same, right? And I hope that's kind of what you try to get out of this, because at the end of the day, building a huge 40 like 32-bit computer you can't do in one workshop. But what you can do is you can build these basic ideas that'll help us get there, right? So I can kind of throw up a chunk of the YouTube video that I thought was sort of evident of logic gate use, and that is, check it out. If I can just drag this over here, boop, you can see that the creator of this video puts down, I guess some blocks here, and you'll notice that they go ahead and place down these torches in a specific arrangement, right? You might think that they're arbitrary, but in actuality, these are deciding the lock itself, right? So he's put down 3 torches, one, two, three, in these positions, right? And if you go over to the other side, this is what it looks like on the back side. These 4 levers. Notice that if these levers are turned on in the same order that these torches are turned on, then essentially the door will open, right? Now that is, I suppose, in its most raw sense, a use of either like inverters or like an AND gate, right? And you can kind of see that in your head, see how that's happening, right? They didn't put it the exact same way that we did, but essentially that's exactly what's going on. The once the lever is on and once the torch is on, right, we're good to go. A circuit or a redstone at the bottom here will kind of figure that out and be like, oh, well, the lever is on and the torch is on at the same time, or the lever inverted whatever's on the torch, and it'll recognize the result coming out there, and you can use that result to open the door, right? So hopefully it's kind of a way to kind of get us started, to kind of get us started thinking about how big of a role that these logic gates will play in designing these redstone circuits, right? And that's the key with redstone design, really. Since it emulates real world digital logic so well, that's why it's been so wildly successful, and that's why people have been able to build these crazy circuits. Usually they're like electrical engineers or digital logic students who are like, well, I mean, I learned this in my digital logic class, so I might as well just build a version in Minecraft, right? And that's how we get these cool inventions like this, piston doors, combination locks, right? They're all just leveraging these logic gates. So thanks to this Turing completeness proof, I say that basically that was me going off on, since we can build these logic gates in Minecraft, we can build literally any computing circuit. There are some other neat computing circuits that we can build that might not be totally one-off obvious, right? So I have a few examples here. One of them is a clock, right? And a great example of an analogy to this is your computer. It has a processor. It might say that it's like 5.3 megahertz or gigahertz to 4.2 gigahertz, right? That's running on a clock cycle. That's a circuit that runs over and over again. And in Minecraft, we can build a very basic representation of a clock cycle. Um, Not sure. Well, actually, no. The Don V is running the server is upstairs, so if this makes a mess on it, then I will be the first to know, I suppose, because he'll bang on the roof that I am currently under. So let's take a look at our little clock circuit here, which is an example of a computing circuit that we can build in Minecraft. So here's what you need to know. A clock is essentially a circuit that has a signal and repeats routinely, right? And we can get this done with, if you remember that we talked about earlier, that Redstone repeaters provide a little bit of a delay. Let's go ahead and leverage that. Suppose in this circuit, I wanted something to happen, something exciting to happen whenever a signal reached around all the way, right? So here's what I'm going to do first. Put down some repeaters here in order to slow down the signal, right? And I'll kind of give you a live demonstration of how that is and how that works. Um, so if I quickly put down a torch, or whoops, quickly put down a torch and break it. Oh, that was too quick. Let's try that again. Or you can also right click repeaters to increase the delay on them. So I'll go ahead and do that. And if I quickly put down a torch and break it, you can see what I've done here. And that is the signal just goes like that and follows the repeaters just like this, in this kind of circular fashion, right? And this is because these repeaters all provide like a little bit of a delay before sending the signal forward. And if we do that in a cycle, we get this really neat design. Now, this is an essential computing circuit because something like this is what drives your computer to kind of process assembly line by line, right? Every time a clock circuit goes around and hits this point, perhaps. Um, exactly. It's plugging extension cord into itself, except by throwing the delay in, it actually works, right? Um, so with something like this, and this is where it gets kind of cool. Suppose you had something like a dispenser, right? So instead of parsing through lines of code, which is for boring people, we can do something neat. We can take a bunch of perhaps snowballs, dispensers, right? And we can go ahead and perhaps, now that we're reliably getting a redstone signal to this little bit over and over again, you can kind of realize what I'm going to do next here. Oh, actually, this might be kind of cool. Um, Go in here, I throw in the snowballs, and you can see that it's just going to shoot them out repeatedly, right? Based on our clock circuit. Suppose I wanted snowballs to come out faster. That's no problem. I can reduce the delay on the clock circuit. And let me just reduce it a little bit more here so you can kind of see. Boop, boop. So they're coming out a little faster. And this is one essential computing circuit that we can work on, right? Um, a clock basically just leverages the fact that we've got wire and we've got a redstone charge running through it repeatedly, right? And this will work. In fact, if you build a lot of these, it becomes somewhat problematic for whoever's running the server, right? So, I mean, this might get exciting, but I think the server's got some solid processing power behind it. So feel free to kind of give this stuff a try, right? And given this clock circuit, you can now do a ridiculous amount of things, right? So let's not just stick to this example. Suppose we wanted to maybe build um, a neat server stopping strobe light. We could totally do that. We could put some lamps here. And the time is day, but we could leverage the clock circuit again to, okay, see, it's already starting to lag a little bit. But if we build a large version of this, then you can totally see how we could have perhaps a strobe light doing things like this, right? So hopefully this is kind of a neat example of how we'd use this sort of stuff to, work with redstone signals and things like that. Ah, of course. Okay. So you to fire snowballs, all I did was so I just basically broke my clock here just so that it wouldn't slow up the server. The item was the dispenser. And that I think will be the final kind of part of my workshop. So while we kind of work through all the digital logic, we've kind of gotten all through the boring stuff that we need to work through. The last few minutes, I do want to talk about some of the neat things that you can use within Minecraft itself, with these AND gates, with these clock circuits, right, to build neat things. So number one, dispensers, they're great. You can fill them with snowballs. We can have flame charges, or I forget what they're called. Fire charges. Okay. Um, So watch, if we put this in here, we can have a slightly more devastating version um, of our previous circuit, right? This will just fire, and hopefully the server. I don't think that'll do anything terrible to the server, but that's fine. That probably shouldn't cause any problems. Another cool thing you can get going, right? So neat little defense here. Um, and to propagate these redstone signals, you can also use things like pressure plates to get a signal started, right? So perhaps you wanted to design some sort of trap, right? And again, these are kind of arbitrary designs that I'm kind of throwing out here. Um, but perhaps you wanted to start firing this as someone walked over something. Well, by using a clock circuit, we can do just that. We can say if somebody walks over this, then oh well, that kind of went a little more than I expected here. Um, but you can use these different. Perhaps a button would be a better way of presenting something like this, right? Again, if you the longer the cycle, the more you add like a delay. You can also add like a pulse limiter to make sure that that pulse coming in will run this clock properly. But things like that will allow us to set up to combine our knowledge of logic gates along with some of these basic computing circuits to produce some pretty neat stuff. Um, so again, I'm here to take questions. And again, I've put this slide in here. We can use these clocks to do all sorts of crazy, like obnoxious things. That's totally fine. But the conclusions that we have here are that Minecraft provides us with some excellent tools to work with amazing functionality. And the key there is that they're so similar to real life constructs that we are, all good. We can use those the same way we would use real life constructs, and that is why it's become so wildly successful. People who know electrical engineering, digital logic, can kind of throw that knowledge together, right? In our case, perhaps discrete structures, throw that knowledge together to put that into Minecraft, um, and have it work exactly as we expect it to, right? With amazing functionality. Furthermore, an interest and background in CS helps immensely in optimizing and taking advantage of this, right? For those of you who have taken discrete or who have gone through a little bit of already, you'll maybe notice that you had exercises in distilling down Boolean logic operations, right? So if you had like multiple gates in one big spaghetti of logic gates, you learned how to condense them down into a few logic gates. In Minecraft, that's saving blocks, right? You could have a bunch of logic gates here and then do some discrete math on it to kind of moosh them down into as little logic gates as possible. Totally viable, right? Um, and of course, we can make strobe lights and a bunch of other neat stuff. So again, since I can't literally show you all of the, digital logic constructs that you can build within Minecraft, I wanted to go over the basics to show you the first few gates and tools that you can produce in Minecraft, kind of prove that we can go ahead and build whatever digital logic circuit we want within Minecraft, knowing these few basic properties. And using those in conjunction with cool Minecraft gadgets and properties, clock circuits, which are, a real life circuit, but we can also leverage this clock circuit um, to do neat things like fire a bunch of fireballs, perhaps at someone's plot. I don't know. Actually, I shouldn't encourage that. Um, but that's exactly what we're kind of trying to get at here. So hopefully this workshop was good, kind of establishing the basics of putting forth. No, nothing of the sort. I said nothing. Oh, actually, it's been recorded. Lies. um, but I hope this provided the basics for everybody. I will be hanging around. I know we're kind of rounding out the end of the workshop here. I will be hanging around afterwards. If anybody has any questions or wants specific help building something, that is totally fine. Um, but otherwise, thank you so much for coming. Build, don't break. Yes, yes, lava is better. Excellent point. I hope this was useful for everybody. Um, and of course, at this point, I kind of open the floor. That clucks at every end. That is amazing. Yes. Okay. I'm glad I helped. Emmanuel, that is solid. You could probably put a chicken spawn egg in here and make as many chickens as you desire on a schedule. Of course. Yes. Thanks so much.